Welcome to this presentation and also a video about building custom GPT solutions. So a couple of days ago, I did a presentation on this, but something went wrong with the recording. So I'm recording it again afterwards. So you can also watch it as a video right now. And this presentation is a follow-up presentation. So there was another session before this from Pieter MbarQ who explains how you can build your custom chatbots on your own data, but it uses like the built-in Azure solutions. Geert talked about that. And this is a follow-up session on, well, if using those methods, it's not enough, well, then you need to go to the code side and build your custom solution. So that's what I will be talking about. Let me also activate this pointer. Let's go. All right, so Geert talked about low-code solutions, no-code solutions. There are options out there on Azure right now that you can just drag and drop or click some buttons and create your chat application based on your own data. So that's really nice. However, indeed, sometimes that's not enough. You need more. And then you need to go to like the pro code. You need to code those solutions yourself. And I will show you how you can do this. However, it's not the goal that you write all of this code on your own. Why? Because there are already many packages out there that have bundled a lot of this code for you, so you don't need to write from scratch. And I will show you this as well. Like I will give an example where you can build your own chatbot that does stuff with like a couple of lines of code, just using these packages. So yeah, it is going pro code, but it's not writing this from scratch. That's not the goal. That's not what we want. We want to quickly develop these solutions as well. We are not reinventing the wheel. Okay, and I will briefly start by once again explaining the retrieval augmented generation principle. This is the same principle that Geert also talked about, but I will do like a quick recap of this. So what is this? Well, let's say a question comes in from a user. And what we do next is we use a search algorithm to find documents that are relevant to answer the question from the user. So we're going to find related information about the question that the user is asking. And this is on your own specific knowledge base. And then we are going to send the results from this smart search. I will look into this further later. We're going to send the result of the smart search together with the question from the user to a large language model. And then the large language model is going to generate an answer. And this is what we show to the user. And then we have like a chatbot or a GPT solution in general that can answer questions based on your specific knowledge base. And there are some components in this, and I will go over all of these components. But the big difference here now is we can customize all these different components, and I will show you how you can do that. And these are the two components I will be talking about. So first I will start with the smart search. Then I will go into how can you do some custom data intake, how can you pre-process your data. And then I will look into creating the prompt. So prompting, which means writing the code or the text that is actually going to the GPT model. Also, we are not creating our own LLMs or anything like that. We're just using components that are out there. And I will talk about using these components for all these parts, right? Because I know this is pro code and you could create your own LLM, but that's not what I want to talk about. And that's not what most people will do for creating these custom GPT solutions. They will use these components that are already out there, that exist, and link them together, customizing them, fine-tuning them, but not writing this all from scratch. One very important thing, Like, why are we actually using this? Why are we using retrieval augmented generation? Well, that's because there's a big limitation in the system, and that is the large language model can only input or receive a certain amount of text. It's limited. The model is limited. We cannot send many pages of text to it. No, it cannot receive that. That's a limitation of how the model works and how the model is built. They are these days building these bigger and bigger and bigger models that can receive more and more and more data in one go. But yeah, this system is kind of also going around this. And maybe in the future, like we don't need the smart search. We can just drop the entire knowledge base that we have into the model without needing to do the smart search. But right now we are using it, and it's a pretty good principle, I would say. Okay, so first thing, the smart search, and there are two components. The first component is the embeddings. We'll talk about that, and then I will talk about the vector stores. So what are the embeddings? Geert already explained this as well, but the embeddings are a way of transforming your text into numbers. But it does it in such a way that text that is related to each other or is pretty similar is also similar when we transform it into vectors. And we use this so we can do calculations and we can calculate how related text actually is. So we can basically do calculations on text, which is really, really nice. And for this, we use a special embeddings model. There are many models out there. They're also black box. We're not gonna change them. We're just gonna use them as a service, or you can even run some of them locally. But we're not gonna customize those. We're just gonna use what's out there. What do you need to know about these models? Well, there are different models out there, and it's very important to know that they are not intercompatible, which means if you start using one of them, you cannot change all of a sudden to a different model because it is trained differently. Behind these embeddings models, there are like trained models with parameters that are tuned right during training. So it's a very specific implementation, and you cannot just start changing them. They also may have like different vector sizes, and so if you start using one of them, keep on using that one. That's important. The one I would recommend, which works really well, is the one that's available in Azure. It's called the Text Embedding ADA 2. But here there's also a limitation because it can only receive 8,000 tokens. You cannot put big text into it. No, it's also 8,000 tokens. So here there's another limit that you need to take into consideration. I will show later how we can pre-process your data to go around this limit. There are some different ways of calculating what the closest distance is. This is something you can play around. There are some algorithms. So far I always use the cosine or the dot product. Those work pretty well. And then a very important thing is that you always need to put in the embedding what you will actually search for. And I will give an example for that. So for one of the projects I did, we created a chatbot that could answer questions about the content of PDF documents. However, when they started using these chatbots, the end users, they were asking questions, but then inside the question they were referring to the names of the files. However, the names of the PDF documents was not included in the embeddings. Only the content was included into the embedding. So it was not really working that well because they were typing something in that was not in its knowledge or not in its searchable data. So that's why you always have to think about what will we actually use, or like what useful information will we actually put into embeddings that we will use for the search. So that's important. So I always like to start the embeddings with something like this: the following information is about, and then here I add like the file name, and then below it the file content, or could be some metadata as well, depending on the case. But yeah, very important, always put in the embeddings what you will actually search for. Okay, that brings me then to vector stores, because yeah, now you know how to create these embeddings. Just use this embeddings model, and that works really well. And always put what you want to search for into the embeddings, very important. Then we have many embeddings. Well, we need to store them somewhere, and we need something that can help us do the search. And that is where vector stores come in. So vector stores are like databases for numerical vector data. And it can help you indeed to do the embedding search. One of the options that many vector stores have is filtering, and I will show you why this is like, well, why I think at least that this is one of the most important features of vector stores. And then you can also do recommendations with some of them, with most of them, I would say. And I will show you an example for that later as well. Okay, for the vector stores, many possibilities as well. Yeah, they all have slight variances and the way that they work, the way they do indexing, and if they are, you can host them yourself, or it's as a service, or yeah, there are many different possibilities out there. I have mostly always used Quadrant, and it works really well for the things I want to do. So I've been using this. But yeah, just know that there are many possibilities out there. So maybe like Quadrant as does not have a feature that you need. Well, maybe you need to look to another vector store. One thing to know is like if you use one of those vector stores that you can just host yourself, or you can run it in like a container yourself, well, keep in mind that you also need to maintain this container, right? You are the one that needs to make sure that this container keeps running the entire time, that you need backups, you need redundancy, you need security and all that stuff. So that's something you need to take into consideration, but there are lots of options out there for you to work with. However, if you don't really want to do that, you want to go, for example, towards a managed solution, then I would recommend looking at cognitive search. So in cognitive search, they added an option to do vector search as well. And that is very promising, because now you have like this managed solution that you don't need to maintain. In Azure available, I think it's still in preview. I'm not sure. I think it's gonna be released soon though. So that's a very good option. Then you also have like the Cosmos DB supports vectors as well. You can do Postgres with the PG vector extension, and Redis also has capabilities for vector search. So these are some good options that are available right now in Azure. And of course, you can always run your own container and run something there as well. Okay, so a little bit about Quadrant. So Quadrant works with the principle of collections. So you could say like a collection is a separate instance, or like a separate an area where you can store many different data points. So yeah, for each collection you can add multiple data points. And one thing you need to know about these data points in Quadrant is that they always require three attributes. The first one is always an ID. Each data point needs a unique ID. If you upload a data point of an ID that already exists, so not a unique one, it will override it. So take that into consideration, that you, well, maybe that's something you want, maybe that's something you don't want, but it doesn't, well, at least the version that I use, it doesn't like protect you against that. But then the very nice thing about Quadrant is you can just add any JSON payload that you want. You can just add your own free JSON object containing metadata, containing basically whatever you want, and you can use that to do filtering on. And that's really, really handy because sometimes you want some extra filtering. And I will show you an example later. And then you can add one or more vectors. So in Quadrant, it's also possible to add multiple vectors. So let's say you have documents that are they are transformed into embeddings. Well, and maybe you add one for each data point, you add one vector of the contents, but you add another vector of the name, for example, the name of the document, and maybe another vector for some metadata. And then you can do some experimentation on which one works better as well. And for certain cases, one works better, or you can do like combinations of multiple, or yeah. So Quadrant has lots of options for that as well, which is really nice. Okay, so this brings me back to the filtering. So how you do filtering? Well, in Quadrant, you just add like this data to the request that you will do. It's called like filter, and then you can say, for example, there is a key in our payload called city, and it must have a value of London, or a key named product, and it must have like a value of Model X. And I will explain you now why this is a pretty important feature in my opinion. So for another project that we did not so long ago, we had to build a chatbot based on manuals about products. However, these products, they had some variations. They were like variants of products, but the manuals were actually very, very, very similar. And this was like giving us an issue that the result from this vector search was actually not so good. So one way to go around this, well, what we did was we asked the user in the beginning of the conversation to select the product that they were having issues with, or that they wanted to talk about. So the chatbot would ask like, "Hello, how can I help you? Do you have an issue with one of these products?" And then the user could just click on it. And from that point onward, we just set this hard filter in Quadrant where we said, all right, now we want to look through all the vectors, because one product could still have like many documents and many pages and lots of text. So it would still not fit into the prompt. So we still had to do the vector search, but we could combine this with like a hard filter that we say, all right, now I want to use the vector search, find the closest vectors, but only for this specific model. So we are kind of combining like these hard filters together with like these soft filters, because that's something you need to know about these vectors or these vector stores. They will always give you something back. So whatever you get back could still be far from what you're looking for, but yeah, it's just the closest one. So they will always give you something back. And with these hard filters, you can say no. If it is not a match, for example, for this key, well, then don't give it back. But this, of course, this searches through the payload, while the vector search searches through the vectors and through the embedding. So that's something you definitely need to take into account. But yeah, the filtering is really, really handy. Like for much of this project, we use it. Like it's good that you know how this works. Okay, so we know how to do the smart search. So there are some options out there. We are not going to create our own vector search engine database. No, we're just going to use what's out there. But there are there are multiple options with multiple features, with different things you can fine tune and configure and all that stuff. But the most important thing, of course, are the embeddings. But now we're going to look at how are we actually going to do the data intake. So for the data intake, you need to remember that the model only supports plain text, right? The large language model can only support plain text as an input. Like it sometimes with these applications it seems so obvious that you can upload PDF, so Word documents, and you can start asking questions about those documents. But in the background, it will always transform this first into plain text because that's what the model supports. But now they're also like bringing out this model that supports images, but that's something different. So yeah, it's important that you transform your model into plain text. And for this, there are like many ways to do this, right? You can use, maybe if you have a PDF, you can just extract it. There are some packages out there that do that in Python. Maybe you need some kind of OCR. Maybe you need like form recognizer from Azure that's available there. There are many ways of doing this. And this is a very custom solution always. Like sometimes one thing works better, another for another project something else works better. So this is something you need to do for each project, I would say. And then you need to, well, then you have, for example, your PDF transformed into plain text, but this is too large. So what do you need to do? You need to split it into chunks. And for the splitting into chunks, there are also many possibilities. For example, you could just say, I'm going to count 500 characters and bam, you split it there. And then I'm going to go another 500 and bam, you split it there. That works sometimes, I would have to say. A better option would be to split on tokens. So you could say like tokens is the language that the model speaks, right? That's what goes into the model eventually, and that's what comes out the model. And then it translates it back into the characters. But like the tokens is what the model uses. And if you use a token split, you can be more accurate. For example, you want to precisely fill in token limits because these models have like token limits. They always talk about tokens here, tokens there. And with characters, yeah, there's still a translation necessary from characters to tokens, which always happens. And you don't know precisely like how many characters is like one token. It's like the average is around 4, but it's not exactly. So if you want to do very precise splits, so you can fill the entire prompt that you have available, which is expressed in tokens, well, it's better to use tokens than characters. I always use tokens above characters. You could also split on page. For example, PDF. It's maybe easier to split on page, but then you need to take into account that you could have, in some case, a page that still contains so much text that it's still too big to fit into the prompt, that you need to split this page into, for example, 2, like in 2 sections. So when you split into page, always count what your maximum token is that you could have in a page. And then you can also split in HTML tags, because what happens now with these characters and token splits, well, we kind of just split randomly. Like we don't look at the actual content, meaning we don't look at, are we splitting in a word, in a sentence, in a paragraph? No, we count it, bam, we split. So maybe that's not what you want. Maybe you want some kind of more clever search and don't split like a sentence or a paragraph. But let's try to split like at the end of the paragraph, like when the paragraph ends. Well, there are also like these HTML tag splitters that will look at, are you, for example, in like an HTML tag, and then it will try to not split inside a tag, only if it is like necessary. So yeah, split on. There are many different ways to do this, and also this is where you can make the difference. Meaning this is where you should actually spend most of your time, like doing the pre-processing, doing the transformation, and doing the splitting, because there are so many variations, so many changes, so many things you can do differently for each single project, that I would say this is definitely the place where you should spend the most time. And if you do this properly, you can also get like a very good result. So yeah, put as much effort as you can in this part of creating your GPT solution. And I will give like a short example. For example, if you have a PDF document, well, there are many different parameters that you can tweak and tune. For example, am I going to split per page? Maybe that's a good way, maybe it's not. Am I going to use some overlap, like using a little bit of the next page as well and a little bit of the previous page as well? In the case there's like a paragraph that's spread out over 2 pages. Then how are you going to extract the text? Are you going to use OCR, or how are you going to do that? Maybe it's better to transform first the page or the PDF into HTML so you can split on the tags. Maybe that's a way. How are you going to do with images? How are you going to process the metadata that's related to this PDF as well? Like, there's so many options out there, and this is like where you have to spend a lot of time figuring out what is like a good solution for your data that you have. Okay, so I talked about smart search, talked about how you can pre-process or do the data intake for your knowledge base. Now I will talk about prompting, meaning the result coming from the search, which is plain text, together with the question from the user. So what are you gonna do? Well, you're just gonna add those two together, and the prompt could look something like this, where you say answer the question based only on the following context, and you dynamically load in this context. So here you could add your, let's say, 5 most relevant pieces of text that you found in your knowledge base, and then you add the question from the user as well. And this is actually what we send to GPT, and then GPT will give an answer. And here again, we have full access to how this prompt looks. So you could say, I want some flavor or some more customization to my prompt. Well, no problem. You can just say, for example, you are a virtual assistant 4, or your answers should be concise, friendly, or they need to be formatted in such a way, or right here you can say everything that you want on how your chatbot or GPT solution in general should behave. So this is how we do it. We just add the context in together with the question, all in one big prompt, send this towards GPT, and GPT will give you the answer. So we kind of did all of that. But now I will go into a way of not having to do everything yourself, meaning there is a package out there called LangChain that will do all these things that I just talked about kind of for you, in a way that they already have all of the code out there that you just can use. So what is LangChain? Well, LangChain is a framework for building applications powered by LLMs. So it's a framework that contains lots of code for you to start building these applications. For example, it has text splitters, it has connections to different models like the OpenAI one or the Azure OpenAI one, or different models also. They have tools, examples, they have lots of pre-written prompts for you already out there. So you can actually use like these default prompts that are already in LangChain for lots of the solutions that you can build. There are connections to vector stores as well. We have these document loaders that do already lots of pre-processing for you. There are output parsers and much more. And this all kind of works with like the principle of chaining, where you say, for example, you're first going to retrieve some information, and then that information needs to go into a prompt, and then that prompt should go into the LLM, and then the result from the LLM should go into a different prompt because we want to summarize this as well, and then this should go into a different LLM. And what you see we're doing is kind of parsing all these input outputs all together in like a chain, and that's kind of what LangChain is kind of built on, but built upon as well. And it is mainly written in Python and JavaScript. I believe at some point they were doing these ports to different languages as well, but I'm not sure what the status is of that. But yeah, mainly Python and JavaScript. And then saying that JavaScript is kind of a completely different version, meaning it's not always the same the way they implement these things in JavaScript, because they also depend on some other libraries like OpenAI and all that stuff. And I would say like the JavaScript version is kind of more of a light version. So if you want like the full possibilities, go for Python, I would say. So now an example as promised. So in this example, I will create a bot. By the way, this is just an example that I found on the website of LangChain. I've never used this specific bot, but it's like, I would say, a good example of how quickly you can build a solution using LangChain. So this example is a agent where you can say, I have an image and please answer a question that I have related to this image. And this is written in Python. So the first thing I have to do is import import LangChain and some tools and some things that are inside of LangChain. Then I will initialize an agent. So I will use an agent that's already pre-written, that's already available like in LangChain. So they already have like lots of these agents that are already out there. You just have to initialize them. And I will also give the agent a tool set. So I'll give it a tool. And in this case, we use this Azure Cognitive Service toolkit, which contains many different tools. So it can transform this image and it can get some information out of this image. So that is using this toolkit. And then as the large language model, we will use an OpenAI model. And then the agent itself, well, we will use this predefined agent with predefined chains and predefined prompts. And we just select which agents that we use. So we import some modules, we initialize the agent, and all we do then is we can just run it. So yeah, this is like written in code. Obviously, this is code. But I would say this is still pretty towards like the low-code solution, meaning you don't need to write all this stuff from scratch. No, LangChain and there are other packages out there that already contain so much things and tools that you can use to quickly write your custom GPT solutions. And with the advantage, of course, that LangChain is also open source. So you can just look at the source, and if there's something that's very close to what you want, but it's not exactly, well, you can just go into the source and customize it. Also, they have like examples, for example, how you can create your custom agent with custom tools and all of that stuff. For some solutions, it's better to use that. But then again, for example, they already contain these connections to Azure OpenAI, so you don't need to start playing around with these REST APIs and doing those REST APIs calls yourself. Nope. Right? It contains lots of things already for you to build your applications quickly. Yeah, as I said, like it opens the door for easier custom solutions because it's also community driven. There's lots of examples out there. Yeah, it's definitely something I would recommend if you start building your GPT solutions to look at LangChain. Or, oh no, first there's a but. There are some issues, I would say, with LangChain. At some point, because this is like a community driven open source package, at some point they were changing this so rapidly. They literally had like a new version every single day. I'm not sure what the status of that is right now. Maybe it's a little bit more stable, but at some point they had like a new version every single day. that's okay, but sometimes I was like writing this code, and then there was this new version with some cool new features that I really wanted to test and play around with and implement in the GPT solutions that I was building. So I would update LangChain, and all of a sudden, all my code wasn't working anymore because they did a complete change in their code base. So yeah, that's one of the issues I would say. Also, there's still this question like, how can you put this into production? Because sometimes it's really hard to see what GPT or what LangChain is actually doing because it's becoming such a big package. And if you use, for example, the pre-built agent that I showed before, well, if something goes wrong, good luck figuring out where it goes wrong. It's not very clear, I would say. However, they are building solutions for that as well. So they have Langsmith, which is available right now. So you can connect your LangChain solution to the service, and this will log lots of things and it will visualize lots of stuff for you to debug it more easily. However, there's still this issue that this runs in a cloud service, or this comes as a service, meaning if you have private or sensitive data, this is not really a solution because you're sending them data to this service. And yeah, as I already talked about, this is a very big library. Like you can customize it, but sometimes if you're not really into how LangChain works, and it can be a little bit difficult finding out where the code is actually written, so you can customize it. So that's also a possibility. Okay, yeah, this is what I wanted to talk about before, but there's also this counterpart created by Microsoft that actually does kind of the same thing. It works on the same principles. It works in many ways in the same way. It's called the semantic kernel. But yeah, this is built by Microsoft. It's, I would say, a far more stable. This is also written in C Sharp, and they also have a Python version right now, I believe. I'm not sure if the Python version is fully up to date with the C Sharp, but it's mainly written in C Sharp. So yeah, this is definitely a good alternative solution to look into. I think, if I'm not mistaken, that this is also what is used behind um, Copilot. Yes. Okay, then you write your code. You can write your code in LangChain. You can write your code in semantic kernel. But then you need to run your code somewhere if you want to, yeah, create your solution in Azure. So in Azure, there are two good options, I would say, to easily do this. One is looking at Azure functions. Here you can just drop your code, just like the agent that I showed before. And you can just run it there. You can trigger it using HTTP, or you can do it with like if a new item in the blob storage is created or something like that, and you want to pre-process this PDF, you want to summarize it or something like that. So that's where you can use Azure functions for. For the Azure functions, keep in mind that they are kind of stateless, meaning that every time you rerun it, it's kind of as if it's the first time that you run it, so you need to keep some state yourself. Then there's also the bot framework. So if you want to go towards building chatbots, so not just GPT, but chatbot specific, I would recommend using bot framework because it already contains lots of stuff for you just for creating bots, right? Here is the same principle. You don't want to start from scratch creating bots and servers and finding your APIs and your, yeah, bot framework does that all for you. So that's really handy. And here you can also still combine it with these flows, these these more static flows, chatbot flows, where you have some parts of your conversation that are like pre-scripted, and then other ones can be more loose using GPT. You can do like combinations, hybrid forms, all of that. And you can also just add your GPT code into the bot framework code. So I would recommend using this one for chatbots, and it's also really easy to publish your chatbot, for example, in Teams or WhatsApp, or There are like lots of integrations with the bot framework and the bot service. So yeah, for chatbots, I would definitely recommend looking into bot framework. Okay, then I will look into two examples before wrapping things up. So the first example is something that I built is, let's say you have lots of recipes, but now you want to use text to find recipes that, yeah, I would like based on my text description. So it's kind of like help me find something. Like sometimes the user doesn't know what they want exactly. Like they don't know which recipe they are looking for, but they do have kind of a description of the things they like and the things they don't. So that's what I will do in this example. So here it's like I would like to quickly make something with pasta and cheese. I don't like onions, and I'm a vegetarian. So that's the input. Okay, and for this example, we're not gonna use GPT for finding the recipe. No, we're gonna use our vector search, of course, right? That's where vector search is really good at. However, we're gonna not do this in a standard way that we just gonna embed this entire text into embedding and then find a result. You could actually do this. I actually did this. I tested this out, but there was a big issue that it had some troubles with, like, sometimes the embeddings are not perfect. They don't have 100% accuracy. And sometimes they were like having this issue that when I say I don't like onions, it would still always include something with onions. But that's not what I want, right? The embedding should be something that's far away from onions. So sometimes like the word don't or like not would still somehow like in a sentence find it something that is close to onions. So what I did here was, before sending this or before creating an embedding from this, I used GPT to extract the things that the user likes and the things that the user doesn't like. So I created this positive vector and I created this negative vector. And I use something like this. Like, this is just an example of how we can do this. So I say like, forget everything you know. By the way, this is the prompt. The prompt that I used for GPT to extract the positive and the negative one. So I start out with like, forget everything you know. You can only respond in JSON format, which is sometimes really hard to make the model do. And then I say like, you're a tool used to extract information from data about the following topics. And then I say, all right, please give me the things that are excluded, so the things that the user doesn't want, and also give the preferences that the user does really want. And then I also, as a bonus, I added like a summary, so you can return a small search summary as well. So yeah, I use GPT in this case to extract some positive and negative words or like lists. And then I can put this into the embedding. So a quick pasta cheese vegetarian. I just create an embedding from this. And then I create a separate embedding from onions and meat. And what I can do now is I can find, using vector search, the vectors that are as close as possible to this positive vector, and at the same time as far away as possible from this negative vector as well. So what I've actually been building is like this recommendation system for finding recipes, and this is like a very neat feature, I would say, what you can do with embeddings and vector stores. So yeah, that's why I like to always give this example, because not everybody thinks about using it in this way. And then I go into the next example. So let's say the first example wasn't enough and you still want a chatbot for helping you find your recipes. Well, For this, I'm just going to use the same retrieval augmented generation principle again. So I use an Azure function, so I did not use bot framework for this one because it was just some testing, and it's easier to write some code in an Azure function, deploy it there, than do it in the bot. So I just, for ease of use, I did it here in an Azure function. And this is where I put all my like GPT stuff and all of that. It's all in this Azure function. And then I used a vector database. In this instance, it was like Quadrant running in an Azure container. I already did like the data intake before, just using some Python scripts. Like it's just a one-time thing. And then for Quadrant, you also need a persistent storage, meaning, yeah, if you just run it in the container, your container shuts down, or you want to reboot it, well, your data is gone. You need somewhere to store your process data as well. And in Quadrant, you can connect this to a file share in a storage account. So that's really neat. And then this all communicates with this small front end. Okay, but before I go any further, I need to do a small intermezzo where I talk about agents, because I talked about agents before by giving an example on how you can build your agent in LangChain. But I actually never talked about what is this agent now and why people use this. Well, the agent is different from the retrieval augmented generation principle in the way that we will not use GPT or a large language model for coming up with an answer, or like rewriting your answer, because it's not coming up with an answer. You want it to use your own data to write the answer. However, now we're going to use GPT for coming up with the solution to get to the answer. So we're going to use it as a thinker, as a creator of steps to getting closer to the answer. And we're going to do that by saying, well, GPT, this question is coming in. You can do these and these and these actions. They are defined as tools. You can also say, if it is, these are like, they are plugins, like in ChatGPT, you have these plugins. Well, they kind of do the same thing, where you say, all right, you have these and these things that you can do. Tell me what you think I need to do now. So then you're going to send that to GPT. It's going to say, all right, I think you need to do this action. Then we're going to actually perform this action. The result from this action is going to be fed back into GPT. And we're going to say, all right, I did this action. This is the question. What do I need to do now? Maybe I need to do another action, or maybe I already have enough information now to generate the answer or to get the answer. So yeah, we're going to use GPT more as problem solver now than just a text answer formulator. So yeah, this is a very, very neat feature, I would say. So another example here again. So with the RAG, we would always go in from question to the smart search. But now, instead of going from the question to the smart search directly, we go from the question to the LLM first. And then the LLM is going to decide, oh, I need to do a smart search. Oh no, I need to do an API lookup maybe. Or maybe, no, I don't need to do anything now. I can just create the answer straight away. So yeah, we're going to use the LLM as a solver of figuring out of what action I need to perform to get to the answer. And there are some advantages of this. So it kind of adds a layer of security, meaning that if the user, for example, does something that is not in any of these things, you could kind of block it off. You You could also maybe add like a tool for like bad things, like a sort kind of like a bin where you say, all right, if it is not any of these things, just answer always with, I'm sorry, I cannot help you with that. So you can use agents for that. It also adds lots more possibilities that now you can, instead of only doing the smart search, you can also do the, for example, calling an API. If you have an API for your company and you want a GPT or chatbot that can answer questions about data that you can retrieve from this API, you can do that. And it also reduces kind of the tokens, meaning that if you would say to the first principle, the retrieval augmented generation, if you just type in hello, well, what it will do, it will look for, let's say, the 5 most related or relevant or closest documents to this message that is hello. However, this is kind of stupid because then we are filling up the prompt with information while the user just said hello, right? So with this agent, what will happen is if the question comes in and the user says hello, it will go to the LLM and it will say, oh no, I don't need any of these things unless you have a very specific greeting tool. Well, then maybe it will do it. But in this case, it will just go straight away to the generate answer and it will say like hi back straight to the user. So that saves tokens because you're not filling up your prompt with all this information that is kind of irrelevant. Okay, let me breathe for a second. Okay, so what I did then is I built this agent using Python and I put this all in this Azure function and I wrote this in LangChain. So I just used the base code of an agent in LangChain and I wrote my own tools. So I did not use a toolkit that's already predefined in LangChain, but I wrote my own tools. And I had these tools available. So it's a recipe search, ingredient search, preparation time, diets, cooking instructions, random recipe, because it's actually really hard to do like, ask GPT to give me a random recipe, but it can only be a recipe that's actually, that's actually in the data, right? You cannot give a random recipe that is not in the data set. No, it needs to be a random recipe that's in the data set as well. So that's why I created a random recipe tool as well to solve that issue. And then the seasonal vegetables. For example, the user could ask like, give me a recipe with like the seasonal vegetables without needing them to type in the seasonal vegetables. Like these ones, they were like, available as a tool. So the agent could ask at the moment, hey, what are the seasonal vegetables right now? And then find recipes using those seasonal vegetables. So all these tools combined added for like lots of flexibility and lots of possibilities. And then these tools could also be looped, right? So first, for example, the agent could look up the seasonal vegetables, and then it's gonna do a recipe search using these seasonal vegetables. Okay, but then there was like one issue, right? Because what I also wanted is to give links back to the original recipes. Well, there was something that was not possible in the agent that I used in LangChain. Maybe it is possible now, but at that moment it was not possible. So what did I do was I dove into the code of LangChain and I made some customizations. So here you see a small snippet out of the prompt. So what you need to know about this agent as well is, at the end of the day, the agent itself is just calling these LLMs again, right? Here. So this is the agent, but the agent is actually just an LLM with a specific prompt. So this is a small snippet out of the prompt. And here you can see the thoughts, the action. So what tool am I going to use? And then must be one of, and you specify the tool names. And then you can also say, all right, what is actually going to be the input of these tools? For example, this tool could be a search, and the action input could be your search query, or this could be a SQL search, and the action input could be a SQL query or an API call, and then some JSON output. So yeah, so it's gonna, so the LLM is gonna spit out a thought. So what is it thinking about? Thought process. So you can follow along. Like, I need to do this and this and this. It's gonna say that. Then it's gonna say, all right, I want to call this action, and this is gonna be the input. However, I extended the code here in a way that I also added that it's always gonna output a list of recipe IDs as well. So when you do the search, like the recipe search or the ingredient search, the output will always be a recipe together with a recipe ID. And that's what's going to be fed as well into the prompt. And then I'm going to ask in this agent, all right, extract me now the recipe IDs that are related to the answer. So it's not just listing the recipes IDs that came from the search. No, it's going to read the result from the search. And then it's going to say, all right, these and these and these recipes are actually matching with what the user is asking. Or maybe it's even going to say, no, I think this one is the best. I'm only going to recommend this one. That's what GPT can do, right? We're going to use its thought. And then it's also going to take the recipe ID as well and spit it out as an output in an array as well. So here it's going to output some text together with the recipe IDs, which is really nice because then I can use the recipes IDs to create a link to the original recipe so the user can click on that. And then for fun, I also added like a follow question. It's a follow-up question, like the thing you see in Teams, for example, where you have like some next answers that you might want to say in your conversation. Well, you can do that with GPT as well, like by saying, all right, not only give me the recipe IDs, the action input, the action, and the thought, but also give me a potential follow-up question that the user might ask. So yeah, I know this is kind of a little bit abstract, but I just wanted to show you that, yeah, you can use LangChain to start writing your solutions or creating your solutions, but then you can customize it by tweaking it, by tuning it. So you can really create your own custom GPT solutions that nobody else has, which is really nice. Okay, this brings me to the end of my presentation, but I quickly want to go over the challenges first. So there are some challenges that I'm still working on, that a lot of people are still working on, and I want to share them with you. So one of them is that, yeah, it's still sometimes really hard to limit down the scope of the GPT model, meaning that the GPT model knows a lot of stuff, right? You can ask it, how big is the moon? And it will answer this. However, if you have created this scientific paper where you prove that the moon is actually not X, but Y in size, well, out of the box, GPT is just gonna answer the thing it was trained on, that was in its training set, what was on the internet, right? It was trained on internet data. So yeah, you can build your own custom chatbot that uses like the RAG principle or the agent principle, that uses your own custom data, where you say, all right, I have this proof that the moon is not this size but this other size. However, sometimes GPT doesn't listen to that, and it still uses its pre-trained knowledge, I would say, is internet knowledge that it was trained on. So yeah, sometimes it's really hard to say, no, GPT, answer based on this context, not your own knowledge. And definitely like the 3.5 model has some listening issues, I would say. And the GPT-4 is much better than that. However, there's no turbo model for the GPT-4 yet. So it's a fair amount slower and also more expensive. And then talking about expensive, it's also still challenging to reduce the tokens. I would say using agents is a good way of doing that. But yeah, if you go towards production and you have thousands of messages with your chatbot each day, yeah, the token cost can come up pretty significantly. So that's also something that's still hard to do sometimes. Like to reduce it, you can do it by doing your pre-processing of your data different as well, but it's always very challenging to do. And then also the guardrails, meaning the result from GPT. Well, can we trust it? Like, can we guarantee that it's going to be a good result, or at least that it's not going to be harmful in any way to the user? And that's also still something that's difficult sometimes. Microsoft is building these things into the models themselves, so they are safer and they will, they will scan for harmful content and they will block or they will stop like once they detect it or something like that. But still, like it's if you go towards production, it's like still hard to do and um, to say like for 100% certainty the model is not gonna behave in a bad way. But yeah, that's just some challenges I wanted to share. So it's not yet like it's not a perfect solution. I would say there's still some things that need to be figured out for it to be adopted everywhere in all the fields. Like most of the projects we're also doing is like more internal. So for internal project, the guardrails it's not really an issue, and the token usage is usually very limited, pretty limited. But yeah, things you should definitely keep in mind. Okay, but I've talked enough. So thank you for watching this presentation, this video. I hope that you learned something from this. Also, if you have any questions, you can always contact me or just leave a question in the comments below. Yeah, thank you for watching.